Alright, it's everybody's favorite time, IXL. Here we go. I'm just going to work some example problems. I'm going to work through the whole thing. Just watch it. We'll talk about taking notes and your strategy as you progress through T.6 one-step inequalities word problems. So here we go. When Edna's phone is fully charged, it can operate for up to 18 hours before running out of battery. It has been 6 hours since Edna's phone was fully charged. Let X represent how many more hours Edna's phone can operate without running out of battery. Which inequality describes the problem? Okay, so it can operate for up to 18 hours, meaning could you operate for 19 hours? No. How about 18 and a half? No. How about exactly 18? Up to 18? Yes. You can operate for up to 18 hours. That's the maximum. It's already been going for 6 hours, right? So the 6 hours it's already gone for plus X more hours. It's not less than 18 because we said it can be equal to 18. So 6 plus X is less than or equal to 18. So so we're going to go with this one. Solve the inequality, then complete the sentence that describes the solution. So we subtract 6 from both sides. 18 minus 6 is 12. If this were a test, you would need to show that inverse operation. That one's simple enough, we can do it mentally, but some of these others I will write out. Edna's phone can operate for up to 12 more hours without running out of battery. There you go. Franklin is drawing a rectangle. The length will be 5 inches, and the area will be at least 20 square inches. Now, if you don't know how to find the area of a rectangle, I'll tell you it's the length multiplied by width. So the length is 5. We don't know what the width is, but we do know the area is at least 20 square inches. Let X represent the width of the rectangle. Which inequality describes the problem? Okay, so we know it's going to be length times width. The length is 5, the width is X. So 5 times X, 5 times X. 20 is on the other side, so that didn't really help us out, but the key word here is at least. The area, well, what's the area going to be? The area is length times width. So 5x represents the area, and this area has to be at least 20 square inches. If I have at least $20 in my pocket, could I have $18? The answer is no. If I have at least $20 in my pocket, I've got 20 or more. Could I have exactly 20? Yes, I could have exactly 20. Could I have 21? Yes. Could I have 100? Yes. So the area, 5 times x, has to be greater than or equal to 20, at least 20. The area is on the left side, has to be at least 20. Solve the inequality. We divide both sides by 5. This is, again, simple enough to do in our head, so we get x is greater than or equal to 20 divided by 5 is 4. The rectangle will be at least 4 inches wide. Got it. Ms. Wells is going to order 4 large cheese pizzas for a class pizza party at the end of the school year. She expects she'll spend at least, there's that keyword there, at least again, $40 on pizza. So if she's going to spend at least $40 on pizza, could she spend $30 on pizza? No. If you're spending at least 40, 40 is the minimum, so it's 40 and up. Could she spend exactly 40? She could. At least means like that number is okay, right? So if I have at least $40 in my pocket, I always think about that. If I have at least $40 in my pocket, I could have $40, I could have 41, I could have 50, I could have 100, whatever, but it's 40 and up. Okay, so she's going to order 4 large cheese pizzas for a class party. She's going to spend at least $40 on the pizzas. Let X represent how much Ms. Wells expects each pizza to cost, which inequality describes the problem. Okay, so I see 4 times X, I see 40, I see 4 times X, I see 40. How much she spends on the pizzas is 4, right? Because she's buying 4 pizzas multiplied by the cost of each pizza. So X is the cost of each pizza. So 4 times X, that's how much she expects to spend on pizza. And she expects to spend $40 at minimum or more than 40. So at least 40. So the amount she spends on pizza must be greater than or equal to 40. This implies she might spend less than 40. Like she might spend 20, she might spend 10, she might spend 5, and that's not the case. She's going to spend 40 or more. So solve the inequality, then complete the sentence to describe the solution. Ms. Wells expects to expects each pizza to cost at least what we divide by 4 on both sides. X is greater than or equal to $10. So each pizza is going to cost at least $10. Got it. Richard is making a budget for his 5-day trip to Virginia Beach. First, he sets an amount of money he thinks he will need for each day of the trip. In all, Richard figures he'll need more than $800 for the whole trip. More than 800. Is he going to use exactly 800? No, more than 800. Is he going to use 700? No. Could it be 801? 802? Yes. Could it be 1,000? Yes. So $800 is more than 800. Let X represent how much money Richard budgets for each day. He's going for 5 days. How much will he budget for each day? 5 times X. That represents how much he spends on the whole trip, right? 5 days, X dollars per day. This is how much he spends, and he expects to spend more than 800. Not exactly 800 or more. He's going to spend more than 800. Not at least 800. No, it's more than 800. So this is it. We divide both by 5. Let's see here. If you divide by 10, that would be 80. So you divide by 5, that's going to be 160. All right, 160. This is one you may want to go to a calculator on. So let's see. Or actually, I'll tell you what. If you go to the bottom right here, it says Windows Ink Workspace. I know you can't see that right now, but it's right next to my clock. And then we got something called the Snip and Sketch. You can use a Snip and Sketch, and I can write on this. So I'm going to get my stylus. So 5x is greater than 800. To solve for this, I need to divide both sides by 5. Okay, now we're going to divide. So let's see here. 5 goes outside, 800 goes underneath. 5 goes in 800 one time. 5 multiplied by 1 is 5. We subtract. 8 minus 5 is 300. Bring down the 0. 5 goes into 30 6 times. 5 multiplied by 6 is 30. We subtract. We get 0. Bring down the 0. 5 goes into 0 0 times. So 160. I think that's what I said earlier. 160 is how much he expects to spend each day. There you go. Debbie works in a warehouse and uses a cart to move boxes. She is loading the cart with boxes that each weigh 15 pounds. The cart has a weight limit of 330 pounds. So a weight limit. Could she load exactly 330 on there? She could, right? That's the limit. That's okay. 330 is okay. 331, is that okay? No, nothing above 330. Is 100 pounds okay? Yes. So it's 330 or below, right? So she's loading the cart with boxes that each weigh 15 pounds. So how many, let X represent how many boxes Debbie can load onto the cart without exceeding the weight limit. So 15 pounds per box multiplied by X boxes. This is how much she's loading onto the cart. So do you want the amount that she loads on the cart to be more than 330? Or do you want the amount that she loads on the cart to be less than 330? I should say less than or equal to 330. We want it to be less than or equal to 330, right? So let's go to the snip and sketch again. All right, let's get a new little snippy snip going. So here we go, snip and sketch. And again, we got to divide. So we're going to divide by 15 on both sides. Divide by 15 on the left, divide by 15 on the right. 15, 330 underneath. 15 goes into 33 2 times. 15 multiplied by 2 is 30. We subtract. 33 minus 30 is 3. Bring down the 0. 15 goes into 30 2 times. So she can load 22 of these 15-pound boxes. So solve the inequality. We did this. X is less than or equal to 22. That's us solving the inequality. Then complete the sentence to describe the solution. Debbie can load at most 22 boxes on the cart. So 22. Way to go, Debbie. 22 boxes. Boom. We're up to 68. Let's keep going. Juan has grown 2 inches since last summer. but he's still not tall enough to get on the crazy carts ride. The minimum height for the crazy carts is 42 inches. Let X represent how tall Juan was last summer, which inequality describes the problem. Okay, so he's grown 2 inches since last summer. He's still not tall enough to get on the crazy carts. The minimum height is 42. Let X represent how tall Juan was last summer. So we know he's not 42, right? Inches, because otherwise he could get on the crazy carts, right? So he's got to be shorter than 42. He was, it says X represents how tall he was last summer. And it says earlier he grew 2 inches. So X is what he was last summer. He grew 2 inches. Still not tall enough for the crazy carts. If you're exactly 42 inches, you can ride the crazy carts. But he's not 42 inches, so X plus 2 is less than 42. We subtract 2 from both sides. X is less than 40. Juan was less than 40 inches tall last summer, so now we know he's just less than 42. Hopefully Juan gets there soon. Oh, what did I do? Oh, I didn't select the right one, right? He's less than 42. If he were exactly 42, he could ride the ride, but he's not. Miguel went to a movie theater and bought a large bag of popcorn that cost $10.49. To avoid spending too much money in all, I think you might have already done it buying the $10 bag of popcorn, but that's just me. To avoid spending too much money in all, he determined that he could spend up to $5.51 on a drink. Let X represent how much money Miguel wanted to spend in all, which inequality describes the problem. Okay, so he already spent $10.49. He's going to spend up to $5.51 more. Could he spend $6 more? No, that's too much. Too much. Can't go over $5.51. Could he spend $5 more? Yeah, he could. Could he spend $1 more? Yeah. How about $0 more? Yeah. Could he spend $5.51 more? Yes, he could. So let's see here. X is going to represent how much money Miguel wanted to spend in all. So the total amount, we don't know that yet. But you take the total amount, you subtract the bag of popcorn he already spent. This is how much in total he's going to spend minus. So this is what's left over, right? And what's left over has to be less than or equal to 551. He can spend exactly 551. So yeah. So let's solve this. We're going to take X minus 1049 is less than or equal to 551. We add 1049 to both sides. And you get X is less than or equal to, this is going to be 11 plus 5, which is 16. So in total, Miguel is going to spend less than or equal to $16, or you could say at most he's going to spend $16 in all. So $16 is what Miguel will spend in total. There we go. I'm up to 82. I want to get up above 90 so we can see how difficult they get. Laura is drawing a rectangle. The width will be 3 centimeters and the area will be at least 8. There's that word at least again. All right, at least 18. If it's at least 18. All right, if I have at least $18 in my pocket, could I have exactly 18? Yes, I could have exactly 18 if I have at least 18. Could I have $20? Yes, if I have at least 18, I could have more than 18. Could I have $10 in my pocket? The answer is no. You have 18, maybe $18.50, maybe $20, maybe $50, maybe $80, whatever, but it's 18 or more. So the amount you have is greater than or equal to 18. But that's going to be the area. The area is at least 18. The width is 3 centimeters. Let X represent the length. Remember, we did this earlier. How do we find the area? The area is length times width. So that's 3 for your width multiplied by your length of X. So 3x right there. That's going to represent your area. So your area, 3 times x, has to be 18 or more, or 3x is greater than or equal to 18. We divide both sides by 3, and x is greater than or equal to 6. The rectangle will be at least 6 centimeters long. That one's pretty easy for a 82-point problem. Danielle has a $30 gift card to T-Shirtopia. She wants to use it to buy a rock band concert and glitter t-shirt. The rock band t-shirt cost $11.95. Let X represent how much Danielle can spend on a glitter t-shirt using her gift card. Which inequality describes the problem? So she has a $30 gift card. So if let's say she has no other money other than the gift card, right? So can you buy something for $10? Yeah, you would have $20 left over on the gift card. Could you spend something for $30? Yeah, you have exactly 30 bucks on that gift card. Could you spend something, could you buy something that's $32? The answer is no, you don't have enough on the gift card, and let's assume you don't have any money left over. So let X represent how much money Danielle can spend on a glitter t-shirt using her gift card. So uh, she's buying this t-shirt for $11.95, okay? And X is how much she can spend on the glitter t-shirt. Okay, so she got the rock band t-shirt, the glitter t-shirt. Rock band t-shirt is $11.95 plus the glitter t-shirt X. And it can't be, this is how much she's going to spend. How much she's going to spend can't be more than 30. Has to be less than or equal to 30. 30 is the maximum she can spend. All right, so let's do some subtraction here. I know you haven't really learned much about working with decimals, but let's see how we do this. All right. So we're going to subtract 11.95 from the left. We're going to subtract 11.95 from the right. So when we do this, it's going to be 30 minus 11.95. Now check this out. We're going to do what's off to the right here? 0, 0, 0.00. We got to borrow. So we borrow from here. That gives you a 2. This becomes a 10. We have to borrow from there. That becomes a 9. This becomes a 10. We have to borrow from here. That becomes a 9. And this becomes a 10. So 10 minus 5 is 5. 9 minus 9 is 0. Decimal. 9 minus 1 is 8. 2 minus 1 is 1. $18.05. 18.05 plus 11.95 is exactly 30. So $18.05 on that glitter t-shirt. 18.05 on the glitter t-shirt. Challenge zone. All right, we're going to do a couple of these and then we're going to call it. It looks like they're not really getting harder, so that's good. Camille ordered 3 cups of coffee from her favorite coffee shop in the first half of November. By the end of November, Camille had earned free refills for ordering more than 8 cups of coffee in a month. So more than 8. So would 8 get you there? No, the 9th one is where it starts kicking in, right? Let X represent how many cups of coffee Camille ordered in the second half of November. So the first half she had 3, X in the second half, and in total she had more than 8, right? More than 8. We subtract 3 from both sides. X has to be greater than 5. She ordered more than 5 cups of coffee. Boom. All right, so yeah, it's not really, I mean, yes, there's some decimals in here. That's a little challenging, but we'll do this one. We'll probably call it. I'll keep going on my own. If it gets more complex, I'll chime back in here. But Lisa had 2 quarts of motor oil in her truck. She opened a new bottle of motor oil and poured in enough to reach the truck's capacity of 6.2 quarts. Let X represent how much motor oil was in the bottle to start. Which inequality describes the problem? Okay, so 6.2 is the capacity. She had 2 quarts of motor oil in her truck, so she added to it and she got to the capacity of 6.2. Okay, so 2 to start in the truck. You add X quarts, and that is greater than or equal to 6.2. Okay, so the left side represents how much motor oil she had, right? So like imagine in her truck, she's got these like quarts of motor oil, and 2 is what she had 2 quarts in the truck. She added X to it. She might have had some left over, right? And how much she has left over. She might have used all of it to reach the capacity, but maybe she had some left over as well. So I don't know. The point is she got to exactly 6.2. So it's going to be greater than or equal to. So how much she has was at minimum 6.2. We subtract 2 from both sides, so x is greater than or equal to 4.2. There were at least 4.2 quarts of motor oil in the bottle to start. She might have had more. There you go. All right. Pretty straightforward stuff from this point. I'm going to pause it and I'll chime back in. Hey guys, so I got up to like 96 and I missed one. So what happened to me was this. I didn't read very carefully. I got kind of lazy with it. Um, in this one, she made more than 400 fluid ounces of punch. If you read the problem, Lexi made fruit punch for her 4th of July party. She split it equally among 50 cups. There was more than 8 fluid ounces of punch in each one. So um, the keyword there was more than, right? It was not at least. If it was at least, it would have been what I selected, but it was more than. So it should have been this inequality. So what do you take away from this? You need to go slow, right? Don't rush toward the end. As you're doing well, don't get overconfident. Still check and double check to make sure everything's in the right place. I got the numerical value correct, but I selected the wrong inequality, which this should be the easier part. Um, Anyway, there is a really good explanation for this. You'll see where it says more than 8 fluid ounces highlighted in green. The explanation for these are great. If you're not taking the time to read the explanation when you miss one, you really need to, right? Because you're probably going to make the same mistake over and over again if you don't read it. So I think a lot of y'all got yourself into that problem over the weekend as you worked the previous IXL assignment. So make sure you read the explanation with the IXL assignment. All right? Thanks, guys. Have a great day.